Magic, I appreciate it. Thank you so much. Yeah, okay. Hi, everybody. Thank you for your patience and thank you for joining me this morning for my presentation on enabling real-time access to field sites using video streaming and Discord. My name is Yesenia Arroyo, and I'm the program manager for GeoSPACE, which is a 2-week field course that's based out of the San Francisco Volcanic Field in Flagstaff, Arizona. So today I'm going to focus on our tech setup for day 4 of our course, where we visit SP Crater or SP Mountain, and we used a combination of cameras, local area networks, streaming to YouTube Live, and Discord to give participants in the course real-time synchronous and asynchronous access to the field sites. So I'm going to briefly talk about GeoSPACE, our setup, and how that combination of tech impacted student learning on this course. So because traditional field courses can deny access to marginalized students in the geosciences, GeoScientists promoting accessible collaborative experiences, or the GeoSPACE project, created a hybrid or blended field course which focused on improving the participation of those underserved students, especially those that had disabilities. The 2023 cohort included 19 students, which ranged from upper level undergraduate to first year grad. 14 of those declared disabilities. That could include anything from mobility and physical disabilities all the way to developmental disabilities and neurodiversity. And then 5 of those 19 students participated in GeoSPACE online. So this could be due to like caretaking responsibilities. We had a student last year that attended that was a parent, or maybe things like an inability to take time off work to attend the field course in person. So in order to make a truly blended course, GeoSPACE sets out to provide as much access to a site as possible. And to do this, we start by evaluating volcanic sites in the field near Flagstaff, Arizona, for ease of access and their academic merit. And then we plan the field course schedule and accommodations according to any disclosed disability, dietary, or other concerns. So we visit SP because, as you can see, it's a beautifully preserved example of a cinder cone, and we try to calibrate their volcanology goggles here to help them later on in the course. But we have a really unique situation where we're trying to provide access to remote participants, but also in-person participants, because if you notice in this photo, one of our rockstar students got stuck in the trail that's leading up to the course. This is actually somebody in a power chair. And it's not just about disability or mobility issues, right? Like even able-bodied folks are not going to be able to explore an entire site. Look at how huge this place is. So they're not going to be able to look at the lava flow at the base of the volcano and look at the cinder cone at the top. Now, if you're interested in learning more about GeoSPACE itself, we're here this week, y'all. Please come see us. We got Michaela Meyer later today, Anita Marshall also later today, and Sean Thatcher on Tuesday. So as I mentioned previously, the students were split into 3 groups. So the remote group was tasked with learning about the site ahead of time by using a combination of tools like Google Earth and JMARS. And they produced a set of questions for the astronauts that are on the ground. They were connected to the site in real time through the use of YouTube Live, which I'll discuss more in a moment. On the left, you can see a really rudimentary map that we drew after going out to scope out the site, and where we plan to put the technology that would help each group access the site. The in-person group was split into 2. So the first group would hike up the side trail to investigate the site from the top of the cinder cone. And then the second group would investigate the site from the base, focusing on just the lava flow from the flank of the volcano. The in-person groups were connected through the use of a local area network. So by setting up this network, we were able to conduct voice calls and video streaming from the top of the volcano to the group down at the bottom. All 3 groups used a really popular instant messaging platform called Discord that, if you haven't heard of, you will hear a lot about from me specifically. So I set up the Discord server ahead of time, and there are specific channels where the students can speak to each other that are event specific. And then as long as we have cell phone signal, we can respond to each other in real time, file share, send annotated photos, all that good stuff. So Discord was an extremely valuable communication tool for our field course because it enabled community between our participants, whether they were remote or offsite. And it did that more naturally than using something like Teams or Zoom alone. So please be on the lookout for a paper that's coming out from me and Dr. Marshall and Trevor Collins on the role of Discord in creating communities of inquiry in hybrid field courses. Little plug. So as far as the remote setup goes, this is some of the equipment that we used for the remote setup, and a really great photo of me and Trevor holding up some of that equipment. So Trevor is holding up a live stream enabled camera, and it's connected by Ethernet cord to a laptop. And in the laptop, I used that to monitor the stream health and also to answer any questions that were coming through on the Discord server. We used a SIM card compatible router and a 4G data SIM card to actually be able to stream data from the top of the volcano to YouTube Live. We set up a predetermined link, and then the students could join live and ask questions through the Discord for Dr. Gallant to answer at the top of the volcano. So you can see here in the Discord chat screenshots that students were taking while they were listening to the lecture and other conversation that was happening. Here is a QR code. I should have warned you. I have QR code heavy. If you have a phone, take it out. Because this is a link, if you're just interested in seeing what the video looks like, resolution, stuff like that, it'll take you directly to that video or a recording of it. We didn't really have, it's also a great way to check out the setup, because I didn't really have great photos of what the setup looked like at the top, because I stayed at the bottom. No, thank you. The in-person setup used a lot of the same equipment as the last slide with a couple extra things. We had a local area network instead of using a 4G signal. So we used these Ubiquiti NanoStation AC antennas, which you can kind of see here on the side. And we used that to beam a signal from the top to the bottom. And then used open source software like Jitsi VoIP to actually connect Dr. Gallant and me so that we could facilitate the questions between the two groups that were on site. Then we used another program called NDI Tools, which is free, it's easy to use, and it's a network standard. It allowed us to stream really high quality video with ultra low latency, so we didn't have a lot of delay between the video at the top and the actual speaking between the two groups. Again, when possible, the students use Discord to communicate. So in this screenshot, a little up close so that you can see a little bit more of the setup that we had in the car. And then in this screenshot, you can see students sharing pictures from the top of the cone to the Discord server for the other students to check out. So the equipment that's used to create these real-time connections is a part of the LIFT kit, or the Library of Inclusive Field Technology. So for more information, here's another handy QR code. You can check out the IAGD website where you can see what type of equipment there is, and you can of course contact Dr. Anita Marshall, the PI, for more information if you're interested in that. So student feedback on this tech. With the remote group, only 2 of the 5 students actually joined the live stream in real time. And those that joined were able to ask questions about texture that maybe they were not able to see in remote sensing, because you're pretty far away when you're looking at that, and usually looking at spectroscopy. And they also noticed surprise at things like vegetation, because if you're working with data from previous years, it might not reflect maybe what the site looked like in real time, and they were able to see that because of the lecture that we provided for them. In the post-field course survey that we conducted, we had a lot of comments from the in-person students, which I will read now. So the video stream enhanced my learning experience and provided wider accessibility. The video relay at SP Crater enabled me to see how the rock features varied at the top, even though I could not travel to that location. As an in-person participant, the live stream enhanced my learning experience because I could go back and rewatch segments from the day, which I totally identify with, because you're out there and whoa, and forget things, so you can go back and rewatch. Another comment says that using technologies to allow all members to see something when not all were able was highly beneficial. So that was great too, because we saw some consciousness from some of the in-person students about how some students couldn't see everything, and they thought that it was great that we were providing that access. And finally, this comment is funny because Well, it says Sunset Crater, but they meant SP, so I don't know if that's good or bad. But, but my favorite tool for communication in the field was the live stream from the top of SP Crater, where those who could not make it to the top were able to listen and learn from Liz, as Dr. Gallant. So some of the issues that we experienced in the field were a little less complex. Things like our microphone had technical issues. So some of the remote students were saying they were hearing a lot of noise in the stream. And even though we went out and tested the equipment ahead of time, you know, sometimes that stuff happens. This is an easy one. Bring extra mics. Test ahead of time if you can, right? And also something that's great was that the sound was fixable in post. So I used Premiere Pro to like remove some of the noise. So when people wanted to go back and listen, that noise wasn't there. Some of the other issues were a little bit more complex. Like we had limited engagement from students at the base. So some things that I thought maybe could have contributed to that was that maybe the TV speaker at the base was not loud enough. And you know, sometimes if you're in the field and if you're overstimulated, there's a lot going on. Maybe if it's not loud enough, you're already going to naturally tune it out. So something that we could do in the future is maybe bring an external speaker to use for the TV. Maybe the activities were also too loose because we kind of like, we have the mission control questions, but we're kind of just like, go at it. So maybe they need a little bit more structure. So that's something also to think about. Maybe backup activities or worksheets, something that will help guide those students that need that extra guidance. Some of them are fine just going off, but for the ones that need it, maybe you can have that on hand. We also had the remote student attendance was low. Like as I mentioned, only 2 of the 5 could actually join us in real time. Again, this is a little bit more complicated to deal with because the remote students are probably taking it remote because they have other responsibilities. So maybe the most that you can do is we've tried to set up the streams ahead of time so that they would know what time and date we're going to do them, and maybe let them know that they have to block out that time like they would a synchronous class, and maybe that'll help your attendance a little bit. We'll see, because we're going to try it next year. And so in conclusion, working with these different student cohorts across the 2 years of the GeoSPACE project, we found that using technology to access the field sites can definitely be an enabler. And it's possible in the field if you're really creative and you're working with a 4G signal and have access to this lift kit. Discord continues to be an excellent application for connecting multiple groups of students on our field courses, but having all the tech does not equal great engagement. So it means that maybe something we have to look at is looking at our pedagogical support to see how we can match the students' needs. They change, they're different groups, so we can maybe look at something there. But ultimately, even though the hybrid delivery could be complex, it's possible and it's necessary so that we can continue to improve access and inclusion in the geosciences. If you're interested in learning more about GeoSPACE, this is my last QR code that will take you to the GeoSPACE website. Thank you for your attention today. That's okay.